Have you ever wondered how almost everything you own gets to you? Your phone, your car, even the food you eat? What if I told you it all depends on one of the largest moving objects humanity has ever built? We went inside to find out how these giants really work, and what we uncovered about their surprising fragility is genuinely shocking. To get a handle on the problem, you first have to appreciate the sheer scale. We're not just talking about a big ship. We're talking about a special category of vessel called an ultra-large container vessel, or ULCV. The biggest of them, like the MSC Arena, can haul over 24,000 standard 20-foot containers, what the industry calls TEUs. If you lined up all those boxes end to end, they'd stretch for over 145 kilometers. If you stacked them, you'd build a tower that blasts right past the stratosphere. Picture a skyscraper taller than the Eiffel Tower laid on its side. That's how long one of these ships is. They can carry a dead weight of more than 240,000 tons. That's like carrying the weight of around 417 fully loaded Airbus, a 380 airplanes. So, why build them this big? The answer is simple and, frankly, a little ruthless. Economies of scale. The bigger the ship, the more you can carry in one trip. This drastically slashes the cost of shipping every single item, making global trade not just possible, but affordable. It's the reason a pair of sneakers made in Vietnam can be sold for a competitive price in a shop in Ohio. These ships aren't just big, they're the engine of globalization. But how does something this ridiculously large and heavy not sink? The secret isn't magic, it's physics, pushed to the absolute limit. It all comes down to a principle figured out by the Greek mathematician Archimedes over 2,000 years ago: buoyancy. A ship floats because its massive, hollowed-out hull shoves an enormous amount of water out of the way. The upward push from that displaced water equals the ship's total weight, fighting gravity and keeping the whole thing afloat. But the hull isn't just a giant bathtub. It's a work of art in hydrodynamic design, sculpted by supercomputers. Up at the front, there's a huge, rounded protrusion called a bulbous bow that slices through the water. Its job is to create its own wave that cleverly cancels out the main wave made by the ship. This dramatically reduces drag and saves incredible amounts of fuel. Now, to push this floating city through rough seas, you need an engine with almost unimaginable power. The engines on these ships are the most powerful diesel engines on the planet. They're so massive, some weighing over 2,000 tons, they have to be assembled piece by piece inside the ship as it's being built. We're talking about engines that are nearly 3 stories high, with pistons you could literally stand inside, generating over 100,000 horsepower. These are complex 2-stroke diesel engines, built for maximum efficiency on long hauls. But that incredible power comes at an environmental cost, igniting a desperate race for sustainability and sparking a revolution in the engine room. Many new ships are now dual fuel, able to run on traditional oil and cleaner burning liquefied natural gas, or LNG. Some ships, like the CMA CGM Jacques Saudet, were pioneers, designed from the ground up around a revolutionary LNG power system to slash emissions. These innovations, from special hull coatings that stop barnacles from creating drag to systems that recover waste heat, are all a part of a race to make these giants greener. But these ships aren't just unthinking machines. For weeks or months at a time, they are floating cities, and they are home to a surprisingly small, dedicated crew. It's hard to believe, but a modern ULCV operates with just 20 to 30 people. That's only possible because of incredible automation. From the bridge, which looks more like a NASA control room than a ship's helm, the captain and officers monitor every single aspect of the ship on digital dashboards. Sophisticated systems track weather and ocean currents, tweaking the route and speed for the best fuel efficiency in real time. But all that tech doesn't replace the human touch. For the crew, life on board is a strange mix of intense, high-stakes work and deep, profound isolation. They work in rotating shifts, called watches, to keep the vessel running 24/7. Engineers babysit the colossal engine, deckhands constantly check the lashings, securing thousands of containers, and officers navigate through some of the busiest, most dangerous waters on Earth. It's a stressful job where one mistake can lead to catastrophe. The crew has to be constantly vigilant, making sure the thousands of steel turnbuckles holding the container stacks together are tight enough to survive the violent forces of an ocean storm. They are the unsung heroes of global trade, living a life most of us can barely imagine, with nothing but the endless ocean for a neighbor. Now, you'd think a system this fine-tuned would be foolproof, but it's not. In fact, its hyper-efficiency is exactly what makes it so fragile. The whole global dance of commerce is built on the philosophy of just-in-time delivery, a system that demands absolute precision to keep costs down. Companies no longer keep vast, expensive warehouses of backup inventory. Instead, a new phone or a car part is expected to arrive at the factory or store just as the last one is sold. This intricate ballet depends on everything running perfectly, all the time, with no room for error. The problem is, the world's entire supply chain is funneled through a handful of critical maritime choke points, impossibly narrow passages these giant ships have to squeeze through. Think of them as the planet's economic arteries. A blockage in even one can trigger a catastrophic global heart attack. And recently, those choke points came under immense pressure, exposing the whole system's terrifying vulnerability. Take the Suez Canal, the 120-mile artery connecting Europe and Asia that handles nearly a third of global container traffic. In 2021, the world held its breath when one single ship, the Ever Given, got stuck, blocking the canal for 6 agonizing days. That one incident halted an estimated $9.6 billion of trade every single day. Then, the system was hit by a second geopolitical shockwave. Geopolitical instability exploded in late 2023, with Houthi attacks on commercial vessels in the Red Sea. Shipping companies faced a drastic choice: risk the attacks or divert their ships. Most chose to divert, sending their vessels on the much longer, much more expensive trip around Africa's Cape of Good Hope. This added thousands of miles and up to 2 weeks to their journey. At the exact same time, halfway across the world, another crisis was boiling over. The Panama Canal, a vital trade artery for the Americas, was being crippled by a severe drought. The canal needs a massive freshwater lake to operate its locks, and without enough rain, water levels hit historic lows. To save water, the Panama Canal Authority had to slash the number of ships allowed through each day, with daily transits dropping significantly. Suddenly, 2 of the world's most important maritime highways were compromised at the same time. The domino effect was immediate and global. Shipping costs skyrocketed. Longer routes meant burning more fuel, paying higher insurance premiums, and covering more crew wages. The disruption caused backups at ports all over the world, straining global supply chains to their breaking point. Experts now warn that if these disruptions and high freight rates continue, we could all see significant price hikes. This isn't a theory. It's a clear and present danger to the global economy, proving that the system that brings you everything you own is balanced on a razor's edge. So, the giant container ship. It's an absolute marvel. It's a testament to our own ingenuity, a brilliant solution to the immense problem of moving staggering amounts of stuff across the planet. But in solving one problem, we've created a new one, a system so optimized for efficiency that it's become dangerously rigid. Our total reliance on these behemoths and the handful of routes they travel has left us all incredibly vulnerable. The industry is now in a frantic race to adapt. They're developing greener ships, powered by things like methanol, hydrogen, and ammonia. They're experimenting with AI-driven logistics and even old-school wind-assisted propulsion to cut costs and emissions. But the fundamental question remains. As global tensions simmer and the effects of climate change accelerate, can our technology outrun the threats? Or have we built a system that is simply too big to fail? And yet, frighteningly close to doing just that? A system stretched to its limits, vulnerable to disruption, where one misstep, economic, political, or environmental, could trigger cascading consequences worldwide. The next time you unbox a new phone or see a container truck on the highway, remember the colossal, complex, and fragile journey it took to get there. If this deep dive into the world of mega ships blew your mind, make sure you hit that subscribe button and ring the bell for more explorations into the incredible engineering that powers our world. What should we investigate next? The invisible web of underwater internet cables? Or the mind-bending logistics of the world's busiest airports? Let us know your pick in the comments below. Thanks for watching.